So we've got a discussion on slope and equations of lines that's separate from the other concerns that we have in that realm of lines and special relationships between lines. So to add on to that earlier discussion, we could have two lines that are related to one another in a couple of special ways. We could have two lines that are side by side, whether that's side by side horizontal, side by side vertical, side by side as far as some sort of, angled line. We could have two lines that are exactly overlapping, whether again that's two horizontal lines that overlap one another, two vertical lines that overlap one another, or two slanted lines that overlap one another. So this is one of the kinds of special relationships that we have. We would refer to these as parallel lines. Whether they are different lines or the same, we would refer to them as parallel. And what that means, though, is that as long as it's not a horizontal or a vertical line, those parallel lines have the same slope. Actually, we can really say as long as it's not a vertical line, then we have the same slope. So in this example here that says find the slope of the line parallel to the one passing through the points 3, 0 and 0, 5, what we're being told are 2 points on one line, and we need to find the slope of a second line. Well, that slope of the second line has to be the same as the first one, so we would need to tidy up the slope calculation and find out what the slope is for that first line. So using our slope calculation and putting our y's and our x's into the appropriate spots, we would end up getting 5 minus 0 is 5. 0 minus 3 is negative 3. We're not allowed to have the negative on the bottom, so we have two choices. Either we can take the negative and kick it out in front of the fraction, or we can take the negative and move it up to the numerator, whichever one you might personally like. However, the point of this particular exercise is that we would need the parallel line, and parallel lines have the same slope, so we have in fact already found the answer that we need. And again, we can write that in those two different ways, the negative out in front of the fraction, or the negative tucked in to the 5 up on top. So whichever way you might prefer. We have another kind of special relationship between lines, though. Other than parallel, we have perpendicular. And so for perpendicular lines, what that means is that we could have one line horizontal, one line vertical, or both lines being slanted in some fashion, but the way that they would interact with one another is that they would form 90-degree angles with one another. We also say right angles with one another. For all the lines that are not the horizontal vertical pairing, all the slanted versions, we have this official relationship that really means if we take the slope of the first line and we change the sign and flip it upside down, we would create the slope of the second line. That's what this means. We would change the sign and we would flip it upside down, and that's going to give us the slope for the second line that we would want to create. So that earlier example, we had just mentioned that we had an answer, and certainly the more convenient one to use in this particular case would be the one where we have the negative out in front. But either way, if we're going to change the sign, then that would mean that the negative is going to become a positive. And if we flip this upside down, then that also means that the 3 would move from the bottom to the top, and the 5 would move from the top to the bottom. So what we would really be looking at here more directly is the slope for the perpendicular line, a positive 3/5. with those relationships, we can actually go ahead and bring back in finding equations of lines as well, which we'll do in just a minute. Just to go ahead and hit that perpendicular business one more time. They've given us a pair of points. That's going to be line number 1 passing through those particular points. If we take the more natural sort of assignment here, the first point is the -2, 3. The second point is the -5, 4. Y number 2 would be a 4. The x that goes along with it would show up underneath -5. Minus after each of those numbers. The y from point number 1 would be a 3, and the x from that same point goes underneath of that, and then put in our fraction bar. That means that our numerator would simplify as a 1, our denominator would simplify as a -3. And again, we don't like that negative down on the bottom, so we either take the negative and put it out in front, or we take the negative and attach it to our numerator. So one of those two. But we want to find the slope of the line that's perpendicular to that. So line number 2 is the perpendicular line. That means that we're going to take our answer here that we just calculated, change the sign, flip it, so that would be, instead of a negative, a positive, instead of a 1 on top, a 1 on the bottom, instead of a 3 on the bottom, a 3 on the top. Change the sign, flip it upside down. That's all we had to do. And so that actually, again, can be a little bit more directly put. The slope for that perpendicular line that we want would just be 3. And then we see here with the example peeking up at the bottom of the screen, if we're asked to find an equation of a line with a particular slope passing through a particular point, then we can go ahead and work through that, right? And then we can use that kind of idea if they extend the problems about parallel and perpendicular to include something like this last example. Find the line passing through these points. So we're going to have to kind of go through a similar example to what we have illustrated here. Once we find that first line, then find the line perpendicular. So second line that we would have to find passing through another point there. That means that we're going to have a 2-part answer here. Line number 1, we need an equation for that. Line number 2 is the perpendicular line. We would need an equation for that one. So line number 1, let's start out with that one. In order to figure out what's going on with line number 1, we're going to need to have a slope calculation for that. And again, we would want to write down our formula so that we can make sure that we ingrain that in our memories. And in this particular case, that means that the specific numbers that we would put into play here would be a 7. Underneath of that would be a 2. The y from the first point would be a 3. Underneath of that would be the x from that first point. Simplifying that numerator, we would get a 4. Simplifying that denominator, we would get a 3. There's our slope. Now we would need to use our slope-intercept form to create the equation that they've asked us to create. So we would pick either the first point or the second point. It is entirely your call which one you might prefer to use. Because the second point doesn't have any negatives in it, let's just go ahead and use that. The y from the second point is a 7. The slope that we calculated was 4/3. The x from that second point is a 2, and we are going to be trying to calculate the b. So that would mean that we would end up wanting to have b equals 7 minus 8/3, which means that we would actually be getting a 13 over 3. So line number 1 is y equals 4 over 3 x plus 13 over 3. Line number 2, being the perpendicular line, means that we were going to take, and let's just make that comment in here, this is the perpendicular line. So we're going to take the slope that we calculated before. We're going to change the sign from a positive to a negative. We're going to flip that slope upside down. So 3 on top, 4 on the bottom. And there's the slope. Now we would use our slope-intercept form of the equation and the point that they have given us in order to find the b and eventually get that equation as instructed. The point that they gave us has a y value of 5. The slope is the negative 3 over 4. The x value that they gave us in that point is a 4. We do not know the b. And what this will mean for us is, though, that b is going to be equal to the 5 plus 3. Hey, that's nice. 5 plus 3 is 8. So line number 2 that we were looking for is y equals negative 3 over 4 x plus 8. So again, the point of the purpose, the purpose of this last example is to show you again that we can incorporate what we had before about finding equations of lines in combination with these special relationships between lines. We could have had this example just as easily say something about finding a parallel line instead, and so we would have used the relationship between parallel lines to have worked that out. But a little bit extra there in the way of examples for building lines once we have a slope and a point, whether it's one point that we've picked out of 2 points or one point that we've specifically been given and we absolutely positively must use that point and the slope that we figured out in order to work out the final equation for that particular line.